Hi, welcome back, Introstat students. So today, I will attempt to do the confidence interval unit test. There's only 9 questions, no quizzes. So let's dive in. Let's see. Right, 9 questions. Okay, so let's get rid of my face. Let's go. Okay, so Corey, first question. Corey wants to use a one sample Z interval to estimate the proportion of his coworkers who drink coffee every morning. He takes an SRS, so we know that so this is to check the conditions, right? Which conditions are for constructing this confidence interval did Corey's sample meet? So there are three. We know there are three. So see if it meets. So SRS. So we know that A is met. The data is a random sample from a population of interest. So a random sample of 10 of his 50 coworkers. So 50 is the population. So if I take 10%, right, zero point 0.1 times 50, so that means my sample size cannot be more than 5, and yet he took a 10. That means I know that the independence rule, the individual observations can be considered independent. This is not it. We cannot pick C. Okay, let's continue. And finds that 6 of those sample drink coffee every morning. So 6 out of 10. So 6 successes and 4 failures because 10 minus 6 is 4. So the both did not meet the this normal condition, right? So we cannot. We just pick the first one. All right. Next one. So let's see. Suppose that the ages of members in a large billiards league have a known standard deviation of sigma equals to 12 years. Hernando plans on taking a random sample of n members from his population to make a 95% confidence interval for a mean um, age in the league. He wants the margin of error to be no more than 5 years. Okay, so um, so let's see which of this is the smallest. So we there's a formula. N is greater than equals to what is it? Is this formula sigma times the z star, right? Times z star, okay, and divided by margin of error, and whole thing square. Okay, so let's see if this works out. So we can plug it in. We know sigma, good. We do not know Z star, but we can find Z star using that 95% confidence. And we know that margin of error is 5, right? So we can plug all those things in. So to find Z star, we need to use inverse norm. Okay, now inverse norm, we need a few things. We need the area to the left, and mean is 0, standard deviation 1. So what is the area to the left? So, oops, that's a horrible normal curve. Okay, bell shape. Nice. Okay. So 95%. So let's say this is 95%. So in the middle will be 0.95. The, the end tail, right here and here, will be half of 0.05 because 1 minus 0.95 is 0.05, and half of that will be 0.025. 0.025. Okay, so area to the left. So this is my z star. This is my z star. So area to the left, right, to put in the calculator is this number plus this number. So it's 0.975. Okay, so what would be the Z star? So 0.975. So go to second vars, inverse norm. The error is 0.975, mean 0, standard deviation 1. Okay, so it's 1.9599. Okay, anyway, this is my Z star. And according to the formula, right, according to the formula, my Z star needs to multiply my standard deviation and then divide by margin of error. What is the standard deviation? 12. What is my margin of error? 5. Okay, so I need to take this number times by 12, right, and then divide by 5. And then I got to square it. So there's a square sign here. I got to square it. Why square? Why square? Because of here. Why? We need to square that number. Okay, so square, and it shows 22. So if you round up to the round one up, right, because you cannot have 22.13 members, you have, it's a whole number that you need. So you round up to the nearest whole number is 23. Okay, so next question. Researchers make a one sample Z interval to estimate the proportion of adults who would say they learned something new in the past month. Previous studies have suggested that about 40% would say yes to this question. The researchers plan on using a confidence level of 95%, and they want the margin of error to be no more than plus minus 5%. If we assume p hat to be 0.4, what is the smallest sample size required to obtain the desired margin of error? So there's a formula. But this has to do with proportion, right? The formula is this: n is greater than equals to p hat times 1 minus p hat times by the Z star, and then divided by actually Z star square, I believe, then divided by ME square. Okay, so so we know what p hat is. P hat is 0.4. So if we write it down, 0.4 times 1 minus 0.4 times, oh, we do not know this, right? We have to know this and then square it. We actually found it earlier, but we can find it again, I think. Okay, so let's find Z star. Now, I don't know if you recall, Z star was inverse norm, right? And I need, remember, three things. Here is the area to the left. And since this is 95%, right? If the middle is 95%, which is 0.95, this tail should be 0.025. And I need to add the area to the left. So this have to add to this, and that is 0.975. So on the calculator, when you go to inverse norm, you have to go to second vars. You pick number 3, inverse norm. Just nice. 0.75, mean 0, standard deviation 1. So it's 1.95. Okay, all that number. So what do we need to do with that? We need to multiply by, so it was what, 1.9, 1.959963. So let's put it to round it to say 2 decimal place, 1.96. Okay, so 1.96. So 1.96, right? You have to square that, divided by margin of error is 5, actually 0.05 then, right? Put it in decimal. And then I have to square that. So work this out okay, in your calculator. So 1.96 square divided by 0.05 square times this times this. So I'm going to try to remember all that and then do it on my calculator. So I need to first and foremost square that number. Sorry, not that. Square that number. Oh, horrible. I need to pick out the last number now, which is that. Square it. Okay. Oh dear. So go to, that's actually not a good one. So second verse, number 3, I need to pick out my z star. So once after I find my z star, I square it and then times it by 0.4 because this is what my p hat is. And then times again by 1 minus 0.4. Okay, so I got that. Then I got to divide by 0.05, but then square, right? So it's 369. 369. Okay. Next question. So Juana is interested in estimating how long it takes students at her school to complete a maze she designed. She takes a random sample of 4 students and records how long it takes each of them to complete the maze. They work separately from each other, so Juana is willing to assume independence. Okay, here are the data with the summary statistics. So player 1, 2, 3, 4. That's the mean, 39 seconds, and standard deviation of that's sample mean is 39 seconds. Sample standard deviation is 8.83. Assume that all conditions for the inference are met for the sample. Wow, that's just cool. We don't have to check conditions. Which of the following is a 95% confidence interval? So we know that the z star for 95% confidence interval is 1.96. So of those 4 options, 1.96, 1.96, 1.96. So I know it's not C. I know it's not C. And it's not E. So it's either A, B, or C. Sorry, A, B, or D. Right? So what is my mean? My sample mean is 39. So I know that my first number, my point estimate has to be 39. Okay, they're all 39. Okay, so A, B, or D, right? That's the answer. So I need to now look at the formula. The formula for a for confidence interval for mean is, what was it? Is this formula. X bar plus or minus T star. Oh, actually, you know what? I might have made a mistake. I was assuming to be T star 1.96, and that's not the right number. We cannot use 1.96. So T star times standard deviation divided by root n, right? Actually, this standard deviation is not the population. Standard deviation is the sample standard deviation right here, 8 point. So in order to write this out, it will be 39 plus minus, I don't know what T star is, but I'll find out in a second, 8.83 divided by root 4, right? Because there are 4, sample size of 4. So root 4. All right, so if I want to look at so it seems like this might be, oh, wait, I need to find T star. So my T star will be inverse T, right? Inverse T and the area to the left, well, since it's 95%, so it's 0.975 at the one tail to the left, and the degrees of freedom is 3. Why 3? Because it's n minus 1. I have 4 sample size of 4 minus 1. So I need to go to second verse and then go down to number 4, inverse t, and then the area to the left is 0.975. So let's check. 0.975, is it correct? Yeah, 95. So I got to add one of the tail to it. And the degrees of freedom is 3. Oh, okay, so my T star is 3.182. So I was wrong. So it's not A, it's not B, it's not D, it's not. Oh, well, it is. So it's either C or D. But C is the better option because it's 8.83, the sigma, divided by root n. Right? So next question. I'm going to pause. All right, so let's continue. Next question is Yuri Yoon is curious what proportion of users will click on an advertisement that appears on his website. He takes a random sample of 200 users and finds that 34 of them click the advertisements. He is willing to assume independence between users in the sample. So based on this sample, which of the following is a 99% confidence interval for the proportion of users that click the ad? So we need, in order to do this question, they're asking us the 99% confidence interval for the proportion. So we need p hat, right? Plus minus z star times it by p, the square root of p hat times 1 minus p hat divided by n. So do we have all of this? We need to find what p hat is. P hat is 34 out of 200, right? 34 out of 200. And that is actually, let's see, 34 divided by 200 is 0.17. So I need to do a 0.17 plus minus a z star of, and z star is affected by, so z star is inverse norm, right, of 99%. So if it's 99%, which is quite a bit, so 99% is 0.99, and this tail adds up to 0.01, and half of it is 0.005, and this will be 0.005. So I'm going to add this area, right, this yellow, because it's area to the left, right? We're going to add because, ladies and gentlemen, because this portion, this z star, this point z star is what we want to find, right? So I need to add this tail and this tail, which is 0.995, standard deviation of 1, mean of 0, standard deviation of 1. So whatever this one gives me is going to come here. And then multiply by 0.17 times 1 minus 0.17 divided by n. N is 200. Hi, Janet. Okay, give me a second.
Your cell phone working already?
Hmm?
Can I see?
Sure. Okay, so where was I? Yes, we need to find out what the z-score value is, the z-star value. So inverse norm 0.995. So if I go to second verse, inverse norm 0.995, and then mean 0, standard deviation 1. So it's 2.576. So of all the options here, D is not it. C and D, because it's P. The very first point estimate should be a sample proportion, and C and D is not it. So we can only look at A and B. But A, the Z star is not 2.576. So the answer is B. All right, so what is the critical value Z star for constructing an 88% confidence interval? So this is actually easy one. So 88%. So if this is 88%, 0.88. So if I take 1 minus 0.88 is 0.12. Now then divide that by 2 because I'm going to put one area here and one area here and they both have the same area. Both add up to 0.12. So 1 is 0.06 and 0.06. And I need to, so this is where the Z star is. This is a positive Z star. This is a negative Z star. And I need to find the area here because the calculator will always want the area to the left. Okay? So I need to find Z star equals to inverse norm of this area plus this area. So 0.88 plus 0.06 is 0.94. Mean of 0, standard deviation 1.94. So let's go to a calculator. Second bars, inverse norm, 0.94, boom, boom, boom. Oh, 1.555 right here. Okay. So here, a critical value. Oh, again, what is the critical value of T star now? So T star, that's interesting. T star, okay, is inverse T, right? And you need two things. The area to the left, right? Area to the left. And DF. DF stands for degrees of freedom, which is N minus 1. So the N here is 18. 18 minus 1. So we know it's going to be 17 here. Now, but what is the area to the left? What is the area to the left? So let me draw out the normal curve. And 90%, which is, say, here. So 0.95. Sorry, 0.90. Which means this area and this area, they're both symmetrical. And they both should add up to 10 or 10% or 0.1. So this is 0.05. This is also 0.05. So area to the left, okay, is 0.9 plus 0.05 is 0.95, and the degrees of freedom, which is 17, 0.95 degrees 17. So go to second bars. Now you have to go to number 4 this time. Inverse T and 0.95 degrees of freedom, which is 18 minus 1, 17. So your T star is 1.73, 1.73. So 3 decimal places, that's a 6 here. 6 will make 9 to 0, and that will make it into 1.740. Okay, 2 more questions. Let's go. Rex wanted to estimate the mean finishing time for the approximately 50,000 finishers at the New York City Marathon. He took a random sample of 10 finishers' time, which was skewed to the right with a sample mean of X bar equals to 271.5 minutes. So random sample of 10 finishers' time, which was skewed to the right. So they tell you that the sample was already skewed to the right. So he's considering using his data to make a confidence interval for the finishing time. So is this a random sample? Yes, because it says he took a random sample of 10 finishers' time. And is it, so there are 50,000 finisher. So what is 10% of 50,000? So 5,000, and he only took 10. Wow. So as long as the sample size is less than 10% of the population size, we should be good. So this works. So what doesn't work is it says here the sampling distribution of X bar is approximately normal. It cannot happen because they say that here the sample size is 10. If it was 30 and more, then the sampling distribution will be approximately normal, but it's not. So, okay, so here we know that B cannot be. So last question, I believe. So Tilda took a random sample of n equals to 17 redwood trees in a park she oversees and had their heights measured. The heights were roughly symmetric with a mean of x bar equals to 60 meters and a standard deviation of 6.1. She wants to use this data to construct a t interval for the mean height of all the redwood trees in the park with a 95% confidence. They ask you what is the critical value T star should tilde use. So again, so T star, which is inverse T, it has two components. One is area to the left, one is degrees of freedom. Here the degrees of freedom is n minus 1, and we were told that the sample size is 17. So 17 is the sample size, 17 minus 1 is 16. So what is the area to the left? Area to the left, I always like to draw the curve. So 95, right? If this is 0.95, the tail and this two tail should have equal area, and they add up to 0.05. So half of 0.05 is 0.025. Half of it is 0.025. And then area to the left, so because this is your this is your T. This is your T star. So area to the left, all of it, area to the left. So it's this plus this, and that gives us 0.975 with degrees of freedom 16. So go to second bars, go to inverse T, and then 0.975, and in this case is 16 the degrees of freedom. So it's 2.12, I believe, 2.12, right? Round to 3 decimal place. So I hope this helps, and if you have any questions, let me know. Thank you very much. Bye-bye.